Let me know if you hear me okay. Okay, I think I'm all set up. Let me know if you're here or if you could hear me. Everything's all good. While everybody's coming in, I'll just wait a few minutes like I always do, just to make sure everything's all good. Okay. Oh, okay. Looks like David's here. Hi, David. How are you? Um, so while we wait just a little bit longer, I'll just talk about what I'm gonna discuss during this session today. So there's three main things I want to talk about. I'm not sure if I'll have time to get through all of them. I'm pretty sure I will. But the three main things are I want to talk about timescale. Timescale is one of the things in Unity that just happens behind the scenes that you may not know about. Affecting the timescale effectively allows you to either slow down or speed up time within the game. Uh, I don't think we've ever talked about it in the past, so if we have, it's been very brief. So I'm just going to talk about how to go about doing that, the different things surrounding it. That shouldn't take that long. Then after that, I want to talk about, because next month you guys will be entering your polish phase for your games. There's an equation called the damp sine wave, which is, actually I have it pulled up here, I'll just show you. We'll get to it later as I said, but this is a damp sine wave. So as you can see in the graph, it like bounces up really fast and then it zeroes out. By adding this equation to some of your game objects and stuff within the scene, it'll add a nice bouncy effect. Hi Natalie, how are you? So that's all nice. I'll show you how to do that. I'll show you what it looks like. I'm sure you'll love it. I love it. It's like my favorite thing. It's beautiful. And then lastly we'll talk about particle effects. Particle effects are its whole thing. So I can't talk about each and every aspect of the particle system. So I'll show you how to do just a few of them, and hopefully you guys could add it to your games and just play around with it a bit more, because particle systems are great. There's a ton you could do with it. It makes your games look really polished just by having them in your game, and a lot of people forget they're there. So it's 4 minutes. It's 3 minutes after 4. We'll just start now. So as I said, the first thing I want to talk about is timescale. So this will be very quick, but as I said, timescale is just affecting the time within the game. So by slowing it down, you can slow down your game, and by speeding it up, you can speed up your game. One thing to note about this is that this is based on time.delta time. So if you want to slow something down, you have to make sure everything affected by it is using time.delta time. If something is moving not based on time.delta time, then changing the timescale won't really do anything. As long as movement is based on time.delta time, or rigid body movement is also affected by timescale, then you're good to go. So I'll show you that right now. It's really simple. So if we just open up the cat controller script and we go to update, I'm just going to make it, actually we won't do it in update. We'll do it over here. So on trigger stay, this is when you hit an object. So when you hit an object, I'm just going to slow down time for 1 second. So for 1 second, I'm going to slow down the time by 50%. So what you just do is you type time.timescale is equal to 0.5. The default timescale is 1. So 1 is normal speed. So 0.5 would be half that. So once I hit something, it's going to change the timescale to half speed. And now I have to tell it to get off of that. because it's never going to change back to 1 after I set it back to 0.5. I mean, after I set it to 0.5, unless I tell it to. So for this, going off of what I talked about last week, we could use an I enumerator for this. It'll make it really easy. So I enumerator, we'll just call it slowdown. And when you use I enumerators, you do yield return new. And you might think wait for seconds, because wait for seconds is what we always use. But wait for seconds is also based on time, the delta time. So you have to do wait for seconds real time, and this won't get affected by the timescale change. So the reason you want to do this is because if I want to wait 1 second, if I want the time to slow down for 1 second, if I do wait for seconds, it would take 2 seconds. Actually, no, it would take 1.5 seconds to go back to normal, because it's going to take 1 and then it's going to slow it down by half. So it's going to take half as long to actually turn off. If I do wait for seconds real time, even if timescale is half speed, it'll still only wait the 1 second before I turn it back in this next line of code here. Timescale. Oh, I could spell. Okay. Equals 1. Okay, so as I said, I'm going to hit something. Timescale is going to go 50% as slow. So for 1 second, I actually have to call the coroutine. Slow down. Okay, so I hit something. I'm going to slow down the time by 50%. I'm going to start the coroutine to wait 1 second before turning back to regular speed. So if I start the game and we actually hit something, you should see that the time goes half as fast. So if I go here, hit this. Oh, I missed. Hold up. No. There we go. Okay. So hopefully you could see that when I hit it. And you could tell I hit it because you could hear the noise when and the score go up. You see that the time gets slowed by 50%. Although it looks a bit janky, but yeah, you can see that it slows down. And alternatively, you could also speed up time. So as I said, 0.5 would be half as fast. If I do 2, it'll be twice as fast. So if you want to see what that looks like, see, I get really fast for a brief moment after I hit the pot. But okay, that's that. As I said, not a huge thing, but in case you didn't know that it even existed, now you know it exists. It's super simple to add, and that's all I pretty much want to talk about with that. So we'll just take that code out and move on to the next thing. Okay, so the next thing, my favorite thing, the damp sine wave. So I guess I'll just bring up one of my projects where I use it, because just so you can see what I'm talking about. So I go to scenes, transition. So we open this up. Hopefully the sound isn't too loud. I'll just mute it. So you see when I hover over each of these text elements, you see that little bounce that they do? That's because I'm running it through a damp sine wave. So that's what I'm going to show you how to do today. It's super simple. It looks really nice. I love it. It's the best thing ever. So let's talk about it. So here's the formula, the beautiful formula. Wikipedia always has the best, you know. You could your teachers always say don't trust Wikipedia, but Wikipedia is good sometimes. So this is the formula right here. It's graphed out so you can see what it looks like. So let's see if I could bring this up side by side. So just so you could visually see the graph and then how it looks in the game. So open this up. So you see right now it's zeroed out. So as you see, this line zeroes out after a while. So that's why it's just not, it's not moving, it's just static right now. But then once I hover over it, it goes to the graph here, and it boosts up really high, and then it goes down and up and wobbly again. I have it very, like, I don't have the numbers going crazy. It's very subtle, as you can see. It's nothing too crazy, but it's just that little touch that makes it look really nice. So that's that. Ooh, let me turn this off. So yeah, okay. So right here, you can see the formula. Some of this might confuse you because it's using numbers, weird letters and stuff, and symbols like pi. But it gives you more information about everything down here, and more formulas down here. But for the most part, we could just follow this one right here. It's a lot simpler to look at, and it gets the job done perfectly fine. So what we're going to do is we're going to convert that into the code. So I'll just keep this open over here and bring up the code again. So the first thing I want to talk about is there's t in this equation. Let me make this bigger. Okay, so there's t in the equation. It just means time. So as time progresses, it runs through the graph. So as time progresses, it runs through the graph. When we start the game, we want it to... It's behind my head. Oh, my bad. Okay, I got you. Wait, put it up here. Okay. Is that better? Actually, I could just check right here. Let's see. Okay, yeah, that's better. Okay. Sorry about that. Okay. So, as you can see, there's e to negative t. Like I said, t is just time. When we start this off, we want to just set time equal to be really high. Because as time goes higher, the graph zeroes out. So, actually, I never deleted this from before, but we have time here. So, float time. We're just going to start it off as 1,000. Because at 1,000, this graph will definitely be zeroed out, and it'll just stay regular as it is. The next thing we want to do in update is we want to just tell time to just always go up, because when we reset the graph, we want it to go up so that it could run through the graph. So we're just going to do time plus equals time dot delta time, and boom, that's fine. Now for the actual complicated part of this is translating this formula into Unity. So what we're going to use for this is, in Unity, each time I hit a pot, I'm just going to make the score just pop, like I had in the text for my other project. So I'm going to hit something, and then the text is just going to do a quick little wobble, and it'll look real nice. So we go here, and we need to add that text. Actually, we already have the text. It's just called TM Pro Score UI. But what we need to do is we need to keep track of the original scale of this object, because where is it? Okay. Because as it runs through this graph, so scale is 1. So the original scale is 1. As what we do is we add the number of the scale of this graph to scale. So once it's zeroed out, we're just adding 0 to scale, so it'll be the default scale. Then once we reset it, it'll add whatever point it's at to scale. And that's what's going to give it the wobble effect. So we need to grab the original scale so that we could add to it. Right now it's just 1, but we shouldn't hard code things because that's not good. So, well, okay, I'll tell you why it's not good. It's not good because if you ever change it, then you have to go back and fix it. If you make it so you don't hard code it, you could change it as much as you want and it'll still work. So we're going to do public float original scale. As I said, it's just going to be the original scale of the text UI. And we're just going to set original scale equal to the TM Pro Score UI dot rect transform dot local scale. So one thing, and dot x, because all the scale is uniform, so each of them is 1, 1, 1, so I could just grab the x and it'll be the same. But as you saw, one thing I want to point out, this is using rect transform and not regular transform. That's because this is a UI element. UI elements use rect transform instead of regular transform. So that's just one thing to note. If you were to write transform in here instead of rect transform, you would get an error. So just in case you ever come up with that issue, make sure to check that it's rect transform. Okay, so now that we have that, we can now move on to the actual formula. So go down here. And what we're going to do is going to just rewrite this equation here. Pop. Okay. So I'm going to make a new float. And this float is going to be called equation add, because this is the number we're going to add to the scale based on the equation. So equation add is equal to math f dot exp. So you might be wondering, what is exp? So as you can see, we have e here. E is another value that's sort of like pi. It has its own set value, whereas pi is 3.14. E, I forget off the top of my head, but I think it's like 2.1 or something. I forget the exact number, but e is its own thing. So what this is saying is e to the power of, and then we're going to put what this to the power of, and as you can see here, it's negative t, which is negative time. So doing negative, and we have our variable here, time. So negative time. Yep, and then plus, next we have cosine. So that's mathf dot cos. And then we can actually fill in what's inside. So right here it has 2 pi t. I'm going to change that just because 2, how do I explain this? That determines sort of the, like how often it ripples. So I want to be able to control this. So I'm just going to make a variable up here that's just called public float ripple speed. And then instead of just hard coding a 2, I'm just going to put ripple speed here just so that we could play with the numbers a bit more. And then we multiply that by math f dot pi. I'm sure you guys all know what pi is. To program that, you just do math f dot pi. This is equal to 3.14, blah, 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 and so on. And then again, we're going to do equation time. Well, just the time. And that's that. So this is the formula that's here. There's a rewritten out. There's a few things I like to add to this, just so that we have more to, like more adjustability to it, so that we could play with the numbers more, make it more unique. So I like to also add an amplitude, float, amplitude, and just at the end of all of this, we're just going to put amplitude. So basically, the amplitude is going to, whatever this is, it's just going to make it bigger. So if I wanted to go crazy, I'd make the amplitude higher. If I wanted to dull it out, I'd make the amplitude smaller. It'll just compress it or expand it, basically, because I'm just going to multiply the entire thing by the amplitude. And there is one more thing I like to add, which is the length of the ripple. The length of the ripple, instead of doing time.time, just adding time here, I like to have a length so that I could control how long the spacing between these ripples are. So this one, I'll just call it public length, public float, length of ripple, and I'll put that right here. ripple. So as I said, this will just elongate. Whereas the amplitude makes the entire thing bigger, as if you, like in Unity, if you were to increase the scale of something, like this is basically what the amplitude is doing. What the ripple is doing is it's basically doing this. It's just going to make it longer. Just more ways to play with the formula. And then, so now that we actually have this equation thing here, we need to actually add this to the scale so that it could affect it. So what we do is we get the tm pro score UI dot rect transform. Again, this isn't transform, it's rect transform dot local scale. So we're going to change the scale because we want it to be bouncy. Equals new vector 2. We could do vector 3, but UI text is 2D for the most part. So I'm not even going to worry about the third variable. So we get vector 2. I'm going to take the original scale. So in our case, it's 1. And then we're going to add the equation to that. So as I said, it's, original scale is 1. So if we reset this equation, we're going to add 1 to that. So now it's 2. Then as time progresses, it's going to change what that number is that it adds to it. So that way it grows and contracts. So 1 second in, it's going to be like 1.4. And then 1.5 seconds in, the scale will be like 0.8-ish. It's just going to run through the equation. So that's the x. And then we also have the y. And we're just going to do the same thing. Oh, actually, we're not going to do the same thing. So the way I have it is... So when we have the equation, instead of just making the entire thing bigger and smaller, like instead of doing this, because this doesn't look as great, as it gets bigger, we're going to contract the x as the y gets bigger. Then as the y gets smaller, the x will get bigger. So that way it looks more squishy instead of adding them the same. Like doing this doesn't look as good as what I had before. I'm going to compress the x as I expand the y and vice versa. So what I'm going to do is instead of doing original scale plus equation add, I'm just going to, I'll put this back up here. I'm going to do minus equation add. So that way it compresses the x as the y, blah, 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 as I said already. So that's pretty much that. Oh, one thing we also have to do is we're going to add the ripple speed to the time here. Not add, we're going to multiply. My bad. Okay. Because, as I said, I want the time to be based on the ripple speed. So if I want to slow it down and fight, whatever. As you can see. So now, how to actually implement this into anything. Right now, this isn't going to do anything because we never actually reset the equation. So what we have to do is, I'm going to make it down at the bottom. Once we hit a vase, it's going to reset the equation. And then it's going to play the animation, quote unquote. So it's as simple as resetting time equal to 0. So by resetting the time back equal to 0, it's going to bring the equation up here. Well, all the way back to the beginning. And that's going to run through it. Then it zeroes out and looks regular as usual. I believe that is everything. So that's good. Okay, that's fine. So let's go back into the project. And we have to put some actual numbers into the inspector. So we have, actually these shouldn't even be public. I don't know why I made them public. The original scale, this should be private because we don't need to see that. We don't need to see this either. The only things we care about are the speed, the amplitude, and the length of the ripple. So, so these are just arbitrary numbers. You could play with this as you want. I don't have any numbers off the top of my head, but from what I recall, I think we just do, let's throw some of these numbers in here. Yeah, that's good, that's good. So I'm just going to hard code the reset to a key because hitting things is hard sometimes. So if input, just so that we can quickly see it, get key down is equal to keycode dot k. We're going to time equals 0. So if I just hit k, it should just run it. So let's see. Oh, that's not right. Okay, wait. Hold up. Let's see. I don't need these. Okay. Time. Yeah, it's good, that's good. That's good. Okay. Okay. Why is it doing that? Let's see. I thought it was that. Time. Oh, I see. No, wait, no, I don't. Plus equals, yeah, that's right. Equation add is equal to length of that plus cosine. Yeah, that's good. Local scale original plus equation add. I wonder if we get rid of these. E is missing? What do you mean E is missing? This is E right here. This EXP. If you're talking about this E here, the EXP is the E. That's weird. Maybe these are bad numbers. No, it's still bouncing. Time is equal to 1000. Set it even higher. Boom. Perfect. Oh. Nope, that's not right. Huh. Wonder what I did wrong here. This new vector 2 original scale plus equation add minus equation add. Let's debug the time. Dot log time. Let's also debug dot log the equation add. Wait. Seems to be changing based on my mouse position. That is weird. Why would it do that? That's not plugged in. Time score, local scale. Honestly, not sure why this is doing this. Oh wait, is it because I changed the time scale? I don't think that should be why, but you never know. So the original scale is equal to that. Maybe this is a bad name. Equation time. Sometimes there are some variable names that Unity doesn't like you to use. Perhaps time is one of them. No, it's not it. Really sorry about this, guys. I ran through this code before class today, and it worked perfectly fine, as it usually does. I honestly don't know why this wouldn't work. The local scale is being increased, as it usually does. Sure, we could do that. I honestly forget where I put that, though. Let's see. I think it's this one. Okay, if you remember last week, we talked about arrays. This is a giant mess of arrays. Although I don't believe it's this one. Oh wait, yeah, it is. Okay, equation time. So we have this here. Yeah, we could just take this, put it here. I played with these variables a little bit differently. As you can see, I don't have the equation. Yeah, okay, that's right. Equation time plus equals that. Although, I don't see this. I think this is still not going to work. Okay. I think it's working. Hold up. Now let's put this back. Equation. Oh, no, wrong project. Okay, put this back here. Oh, okay. So it does work. I have no idea what's different about this than the other one. Perhaps there was a variable that was 0, and it zeroed out some of the things. I'm not entirely sure, but we could play with the variables now. Again, really sorry about that. That was a big mess. I'm not sure why this wasn't working the first time, but we'll make this amplitude. Do that. And this is the length of ripple. And this should work. Let's go back to cat. Everything's 1, 1, 1. Okay, so we have this. That works now. And now we can play with these numbers. So if I make the amplitude, let's make ripple speed 10. Oh, okay, that's really fast. It runs through it almost instantly. Let's let's make amplitude that. So this one goes a little bit crazy. Let's make this one 0.25. That makes it even slower. Number 3. Oh, we're making progress. Oh. 3. Okay. I'm not going to spend here a whole bunch of time fixing all these numbers because I already wasted a lot of time trying to debug that. Again, sorry about that. I'll bring up this formula just one last time, just so that if you want to copy it down or anything, this one works. I'm not sure why the first one wasn't working, but this one is fine. And what we're going to do, instead of having k change that, I'm going to go back down here and make equation time equal to 0. So let's say when I hit something, oh, can I put in chat? Yes, that's a good point. Take this, put it, okay, that's a big mess. And then I'll also put the, when I change the scale of something in here. That looks like a mess, but if you were to copy and paste that into one of your things, it would look right. So there's that. I made it so that when I actually hit something, it'll run the code. And those are 3. Okay. So once I hit something, oh, there we go. So you see it does a little bounce. Oh, looks like I'm stuck in this. But you get the gist of it. Again, I'm really upset it didn't work the first time, but at least we got it working in the end. Just play with those numbers, as I said. Just by changing all those numbers, you can make it look real nice. But go back here. If you just look up damp sine wave, this will be like the first search results. If you ever want to refer back to this, or you want to look at these different equations here, some of these are a hot mess, and the wording is very confusing. So I just stick to this one here. It works perfectly fine. It looks really good. And oh, one thing I did want to also say is I have cosine here, but if I were to change this to sine, it would change the formula just as slightly, so that cosine starts up here, but if I make it sine, it would actually start at 0. So it'll actually look smoother because it won't just instantly snap to a different position. It'll go from its original position and then back. So now that I've changed that, I'll just show you one more time. Ooh, so put this. Okay. So it's a very small change because of how fast it happens, but I hope you could at least see, like, okay, got it stuck on a wall now. So, okay, so you see how it I don't know. I can see the difference. I think it looks way nicer because it doesn't just snap to like that bigger position. It actually starts and then gets bigger from its original position. So that is one modification that you just have to remember off the top of your head to change to this, because this is going to start up here. But if you make a sine, it'll start down here and then go up and down. It's a small change, but it adds a bit to the project to make it look a little bit nicer. So, one more time, just to clarify, if you want to make it so that that equation actually runs, you have to reset the time back equal to 0. Yeah, it works on more than just UI elements, because, as I said, if you look at this formula, it's just going to add a value. So pretend any point on this line is a value. Like right here, now the value is 0.5, then it's 0, negative 0.6. It's going to add whatever that number is to whatever you, like, I added whatever value this is to the original scale of the UI text. So theoretically, you could add this to a regular game object. One of my friends I showed this equation to, he made like a ball, and then he just used the same scale thing. So each time you land on the ground after jumping, it would do the little squishy thing, and it looked like a nice little squishy ball. You could do this with rotation, if you wanted to just like rotate real weird. There's various things you could do. Just remember that we're just adding whatever value this is to whatever, and then eventually it zeroes out. So in this case, I'm just adding it to the scale. And to answer your question, yes, it does work on all UI elements. It works to anything that has a scale, honestly, because we're just adding a value to the scale. So we're just adding a number that goes up and down really fast in a nice smooth and bouncy way. That's pretty much all the formula does. So that went on for a little bit longer than I wanted it to, but so we'll move on to the particle effects now. So as I'm sure you know, or if you don't, there's the particle system, which you could add to a component. You could just add this to anything. And I'm actually not going to put that there. Let's go back down here. Create empty. Okay, so now it's here. So you create a new particle system, and you just get a bunch of these purple squares. So we want to change that. So not only recommended, I just show this little snowflake thing, because that'll look nice. So if you want to add the snowflake, you have to check off texture sheet animation, and then go to sprites, and now we could actually add a sprite to this so that it's not just the square. So you add this, and then you're like, oh no, nothing happened. That's because you have to change the material that's on it. So since we're using a 2D sprite, we use just this right here, and look, now it's a snowflake. So now we have a nice little snowflake thing. So if you wanted to, you could just have this rotate downward. Boop, boop, boop. Whoa, look, now it's just snowing. But okay, that's not what I wanted to show. But that was just a quick little adding sprites to something. But what I did want to show is the different things you can do within the particle system itself. As you can see, if I minimize this, like there's just a ton of things. Like each of these open up and they're their own thing. There's a ton you could do. We could spend hours just talking about the particle system. There's just a few things I wanted to show you. So I'm going to make a new particle system that's not going to be a snow one. And we're going to make a nice little explosion particle effect. So we're going to make a new particle system. Go back here. We're going to add another, I'm going to add a sprite to it again. I'm just going to add a star. And then again, since it's a sprite, we're going to make sprite, add that to it so that it shows the sprite itself. One thing I should point out, once you add a picture to the project window here, the asset folder, make sure you change it to sprite 2D and UI. By default, it's default, as the name suggests. So you have to make a sprite 2D and UI, otherwise you won't be able to drag it onto this little thing here. So now that we have this, this is not an explosion particle effect. So what do? I recognize that star. Oh yeah, it's the same, that's my temporary star I have for this. Yep, beautiful. Temporary sprites are great. Okay, so first thing, we're going to change the shape. So right now it's a cone. Battle emotion. Yeah. So not battle emotion. Yeah, so as you can see right now, it's emitting in a cone. So if you could visualize, as you can see with the little wireframe it has here, it's a cone. So it's shooting out at a cone. So we don't want that. In an explosion, we want it to be a sphere, because we want the particles to just shoot everywhere, in every direction. So there's a little drop down here, and there's a bunch of things you could choose. You could play with these. As I said, There's a ton of options. We could spend hours doing this, but this is going to be a quick little thing because we're running out of time, unfortunately. Perhaps I'll bring this up in a future one, but okay. So as you see, I made it a sphere, and now they're just shooting in every direction. But this doesn't look like an explosion either. So what are some other things we have to do? So first of all, if we want to do a nice little explosion, oh yeah, I guess we can go past 5 too, yeah. That's also doable. Yeah, we'll just do that. We'll just go past 5. Obviously, you don't have to stay the whole time, but I'll be talking about it. Okay, so we have the sphere thing, and as an explosion, we don't want it to just continuously go. We want it to do, like, the burst, and then just stop after that. So, for this little thing I'm going to show, whenever I hit a vase, I'm just going to do a little explosion particle effect, and then that's pretty much it. So, first thing we're going to do is we're going to turn off looping. By turning off looping, it's going to only play the animation for as long as the duration. So if I hit play again, you'll see it only ran like the particle system for that 1 second, and then it stopped. So we're making progress, but this isn't exactly a nice explosion as we want. So some other things we could look at, the start speed. We might want to play with that just so that the stars shoot out faster initially. So let's do that too. 1 second is also too long for an explosion. Like, okay, I guess that's fine. But now it's only shooting 2. That's because if we go down to the emission, it's the rate over time is 10. Yeah, it is per second. Okay, so basically per second, it's going to shoot 10 particles per second. So since I changed the duration to 0.3, it's only going to shoot 2 because, like, it only does 10 per second. So if I were to make this higher, like 60, you'll see now it shoots out way more. Because now it's going to shoot out 60 stars per second, and if I'm only going to run it for 30, it's going to run roughly 20-ish particles for the duration. So that's one thing. Another thing that's really good is the size over lifetime. This is another thing I really like, because as you can see here, oh wait, let me turn this off for a second. So the stars, they just go, and then I should probably, okay, they go on for 5 seconds. Okay, we're going back. Sorry about that. This is the lifetime of each particle effect. We should probably make that a lot shorter, because having the particles last for 5 seconds is just way too long. Because when an explosion happens, it does the initial burst, and then that's pretty much it. If it does the initial burst, and then just the stars just fly away for 5 seconds, that just looks weird, in my opinion. So if we change this to 0.4, you'll see they only last for 0.4 seconds. But you see how they just disappear just after that 4 seconds? I don't like that. So that's why we're going to turn back on the size over lifetime. Now by having this, you'll see this little graph here. So you click on it, and then it'll bring up this little window here. If you don't see it, it's because it's like this. Just click on this here, and then it'll come back up. So this graph is basically showing how the stars grow. So if we do this again, you'll see they start off small and then get bigger and then disappear. That's because the graph is starting at 0 and then it goes up to 1. So within its lifespan, the lifespan is only 0.4. So this number here is after 4 seconds, its size is going to be 1. 0.2 seconds, it's going to be 0.5, etc. We want it to be the opposite, because we want it to start off strong and then fade away. So what we could do is grab the little notches here, the little dots, and you can just drag it up. And there's also a little thing here. I hope you could see that well. Actually, I hope my face isn't in the way. Hold up. Wait. I'll just move my face. Oh, wait. Okay. We're going over here. Okay. Hopefully you see this better. See this little gray notch here? You could wiggle this up and down. You could play with this as you want, but I think this is good. So we do this, and you'll see they just go, and then they fade out of existence. Instead of just disappearing after the 0.4 seconds, they actually just continue to get smaller until they just disappear. In my opinion, that looks way nicer. We could also have them expand in size as they get created and then get small again, which could look nice. Like, that does look pretty nice as well. These graphs are just like everything else I'm going to talk about with the particle system. You just play with it until it feels right. There's no like set answer to anything regarding the particle system. It's a lot of trial and error. You could hit the restart button just to quickly look at it again. So there's that. Another thing we can do is the velocity over lifetime. No, actually, not this one. It's the limit velocity over lifetime. So, whereas the size over lifetime makes it so that it gets smaller or bigger throughout its lifespan, limit velocity over lifetime basically slows it down after a certain amount of time. So, if you make this 0 and you dampen it by 0.5, and let's just bring up the little descriptor here. It controls how much the velocity that exceeds the velocity limit should be dampened. The value 0.5 will dampen the exceeding velocity by 50%. In short terms, basically, like once it reaches a point, it's just going to slow down by 50% because I put 0.5 here. And if I play this here, you'll see they don't really move because they're just getting dampened really fast. So let's change that. Okay, that made it a little better. Okay, we're making progress. Let's make the start speed 30. Okay, that looks pretty good. Let's lower this number just a tad. Oh, no, actually I want to increase it. Sure, okay. Okay, so it's looking a little bit nicer. I'm going to say this a bunch of times. Hopefully I don't get too repetitive, but it's just a bunch of trial and error. You just play with these numbers until they look nice, just as I'm doing here. And let's see if there's anything else we want to do. You could also change the rotation over its lifetime. That could give it a nice little effect. Like I said, I'm not going to touch up on every single one, but let's just end off on this one. So they rotate. Let's make that higher. You could also, another thing I should bring up, this little triangle on the side here, there's different options you could choose from. So as you can see, just by having a constant, they all move in unison at the same speed rotation. That's because it's just a constant 360 degrees. If I were to open this up and make it random between two constants, yeah, there we go. Between two constants, it'll just pick a random number based on whatever this is. So if I want some of them to spin as they did regularly, I would just keep it at 360. Let's say I want some of them to go the other way. Then I would do negative 360. And it's just going to pick a random number between negative 360 and 360. So you get a good variety of rotations going on here with the explosion. And again, that looks a little bit nicer. So when you make your own particle effects, I would just look at each of these and see what you could do to just make the particle effect just look slightly better. There's a bunch of things you could do. And I'm just going to lower this a bit. Okay, so that's good. So now actually implementing this into the game. I'm not going to go too crazy over this, but let's attach this to the cat player. And I'm just going to put this like right on his nose. So that way, when I hit something, I'm just going to play the particle effect and there'll be a little explosion here. Although, as you can probably see, this is really big. So we could also change the scale to make it smaller. And okay, that's good enough. Let's just put this on his nose. Okay. Let's make it a little bit smaller. Okay, so that was a little effect here. So now how do I actually add this to the game? I'm gonna go here. So, as I've said in a past video, if you ever want to know how to get something, just look at the component name here, and then that's just what it is. So, if you go back here, we're just going to type in public particle system, because it's a particle system, and we'll just call this explosion effect. And in order to play that, it's as simple as just, okay, so right here, when we hit something, we're just going to do explosion effect, that's the name of the particle effect, or the particle system, dot play. So it's just going to play the particle effect, and that's it. It's as simple as that. So, oh, I need to actually add the component to the cat, which I did not do. So go here, particle system, which is this one. Let me rename this. Okay. Boop boop. Oh, actually, one thing you might have noticed, you saw that on the beginning, it played the particle effect a single time. That is one thing I forgot to keep it. Accounts for. There is a play on awake right here. Play on awake. If you don't want the particle effect to start when you start the game, make sure that's unchecked. So now that's unchecked, it's not going to play in the beginning. So once I hit something, whoa, look, there's a little particle effect. It's crazy. Now, like I said, I could spend way more time into making the effects look way nicer, putting better sprites on it or whatever, but I just want to show that. So you could just make a particle effect like that, play with the variables, make a little explosion thing. One other thing I do want to talk about, because it is pretty cool, is you could hit the plus thing here, and you could add another sprite to this. Oh, actually, never mind. Okay, what you do need to do is you need to make sure they're part of the same texture animation thing. So you guys know about splicing. So let's see if I can find something I could splice. Here, like this. Okay, so we're gonna splice this. We're stealing this. We're hijacking this. Go. So you make it a sprite. As you saw, I made it a sprite because it originally wasn't. I'm gonna make it multiple, and then we're gonna go to the sprite editor, apply changes, and we're just gonna slice it, slice, and now they're each little own sprite. Hit apply, go back. So you see they each have their own little sprite now. So if we go back to this thing, where did I put it? Okay, right here. And we just put these in here. And we could we'll add a bunch. So we do this. So basically what I'm doing is I'm just adding a bunch of these sprites here, so that once you run the particle effect, it's just going to randomly choose a sprite from here. So as you can see, it's just going to randomly choose them. So in case that's something you ever wanted to do, I'm not sure. I think it's pretty nifty, so I wanted to point it out at least once. You could do that. So I just wanted to say that. So it is 5, but as I said, I'm going to go a little bit past 5 because there's another thing I want to show, because it's also pretty cool. It's called, I don't know what the name of it is because I don't think it has a name, but it's like a trail particle effect. So basically, as you move, the particle effect will play behind you. You know what? It'll make more sense when I actually do it. So making a new particle system, and basically it's gonna play the particle effect based on the speed of the object. So go here. We're gonna add the star again. It's just my default go-to test sprite. Sprite, star, boom. And then once again, this is a sprite, so we're gonna take this material, and what we want to do is we want to make it so that it emits based on speed. So there's a few things we have to do for it to do that. First, we don't want it to loop. We do want it to, actually no, we do want that. Where is it? We want to, boop boop. There's a few things we have to do. So first thing we'll do, okay. As you can see in the emission, it's gonna emit 10 particles per second. What we want to change about this is instead of doing time, we're going to do distance. So basically, I'm not sure what the units, yeah, per distance unit. So it's probably taking unity units. So for every 1 unity unit, this particle effect moves, it's going to emit 10 particle effects. So right now, we need to add this, let's put more here. And there's a few things we want to add. That's good. That's good. Oh, no, that's way too much. Okay, I just forgot to hit the play button. Boop, boop. Okay, so we're playing. So as you can see, as you move, it plays the particle effects. So right now that looks terrible, because as I said, there's a bunch of things you gotta play with it. But what you could do is you could add this to the player, and then it'll play this particle effect behind him as he moves. So let's just change this up real quick. Make this 0.5. They'll last a lot shorter. We'll change the speed to be like 1, so that way they don't go crazy. We could also make this a lot smaller, so there's not too much, although it's still a lot. 1. Here we go. Okay, that's slightly better. Change the lifetime. We don't want them to last incredibly long. That's a lot. 0.2. Oop. Okay. Do that. Then we want to do size over lifetime. That way it doesn't just disappear. As I've already said before, we want it to sort of fade out of existence. So now it does that. I'm not going to go too crazy making it look all incredibly fancy, because as I said, we could spend hours doing that. That's not the point I'm trying to get across. I'm just trying to show that this type of particle effect exists, where as it moves, it makes particle effects. So theoretically, you could make this follow the mouse, and then your mouse would do particle effects. But I'm just going to show it as part of the player. So one thing you want to do again is the simulation space. You want to change it to world, because we're going to attach this to the player, and because it's on the player, it's going to technically not be moving, because it's the player that's moving and it's just the child of it. If I make it world space, it'll recognize its own movement, so that it could actually emit the particles as it moves. Scaling mode. Yeah, okay. This one we want to be hierarchy, because we want to scale it based on its own thing, not based on the cat, because its cat is its own thing. So it's like 0.5 right now. We want to make sure the particle effect emits like the size we set it to. There's a lot of small things to it, but sure, we'll just do this. And we'll put this on the cat. Let's actually move it over. Um, and pre-warm. Okay, so the pre-warm, I honestly forget exactly what it does, but when you do a trail render, well, a trail particle effect, you need it to be pre-warmed. So it says when played, a pre-warmed system will be in a state as if it had emitted one loop cycle. Can be used if the system is looping. So take what you will with that definition. I forget exactly what it is. Sorry about that, but that is something you need to have checked off if you wanted to play properly. And I think that's everything. So let's just run the game, see what happens. Boop, boop. Okay, so sort of looks like a mess right now. We could fix that, but as you see, now there's little sparkles coming behind him, and then when you stop moving, the sparkles stop going. And then they're back, and whatever. So, there's that. Like I said, we could spend a lot more time making it look nicer. As in, changing the shape. Probably want this to be sphere. And etc. There's a bunch of things we could do to make it look nice. But, I think I'll just leave it at that. Because as I said, I just want to give you a nice little... Yeah, I'm going to fix it anyway. It's making me sad. Okay, we're going to put this like over here. Here we go. Make that look nice. Probably make this smaller. Let's make it 0.5. Boop, boop. Okay. Oh, no, that's not right. We want it to be down here. Paste. Okay. Almost there. I promise. It's almost there. Okay, it's just a little bit too low. Okay, this is gonna be the last one. However it looks, this is how it looks. Because that's not the premise of what I'm trying to say, but... Okay, that's close enough. Okay. It's like, oh look, now there's little stars coming behind him. Isn't that fancy? It's crazy. But, that's that. Hit something so you can see the explosion again. Ugh. Whoa. Explosion particle effects with emoticons. And then look, now it's all bouncy. So, pretty much the premise of this entire thing was little bits of juice you could add here or there just to make it feel better overall. Each of the things we add don't add a whole lot to the game, but they add something to it, and the more you add, the more of the little somethings you add, it'll add up to be like a nice big, nice project where everything feels more alive. Like, just like look at the score when it hits something. Like, yeah, I could fix that to make it not as aggressive, but doesn't that just like, it feels good. It's like, oh, that's my score going up. I hit something. Isn't that great? And then also you have a nice little visual indication of you hitting something with the emoticon particle effect. It's like, whoa, look, a little particle effect. It makes you want to keep doing that so that you could keep on getting the particle effects coming. The little trail behind you, it just adds a little, like I said, it just adds a little bit of juice to the game. It's just, because the walking animation, it's like, okay, that's a nice walking animation. But now it's like, oh, look, I'm all glittery now. That just feels, as I said, not a whole ton better, just a little bit better. It's like, oh, that's nice. He has little sparkles coming behind him. And now with the snowflake particle effect I have there, it sort of builds the environment just a bit. It's like, oh, there's something happening around me. That's not just me in this Unity project. It's snowing out here. Going on a bit of a rant, but the premise of the story, juice is great. Please add it to your game. It doesn't change the actual mechanics of the game, but it just makes it feel better. It adds more visually appealing things to look at. Like, you know, it looks nice. But, like I said, I'm going on a rant. That's pretty much all I had to say. Again, sorry that the damp sine wave thing was having a bit of an issue. I don't know why that happened, but it did. So, sorry about that. Hopefully, you did learn something new, though, because I love damp sine wave. Please put that everywhere, because it looks amazing. It's gorgeous. It's the best thing ever to exist. Damp sine wave. And, oh, also, slowing things down. If you want to add dramatic effects, change the time scale, as I showed in the beginning of the video. Sometimes just slowing things down, it's just like that little bit of satisfaction that's like, oh, I hit something, and then it slowed down time, because that's just how powerful it was. But I'll end it there. I'm going on a rant. But that's it. Hopefully you learned something new. Please add juice to your game. Again, you have a whole extra month to work on your game, so please add juice to it. Make it look beautiful. Play around with the particle effects, because particle effects are great. And that's all I have to say. We have more videos coming soon, and I believe Natalie said she'll be playing your game. When's it due? I'm actually not sure entirely the specific date, but it should be the end of May. Okay, so yeah, Natalie will tell you in the next video when it's due, but it'll be sometime in May. Maybe a little bit after or before. I'm not sure. As I said, I don't know. You'll find out next week. But, okay. That's it. Yeah, tune in on Monday. That's all I have to say. So, thank you for watching, and hope you learned something new. Bye-bye.